My name is Andy Gilbert, and my co-authors and I work for the Illinois Natural History Survey at the Forbes Biological Station. We have monitored the vegetation community at Emiquon since the start of the restoration, and today I'm going to discuss how it has changed over time, with a special emphasis on submerged aquatic vegetation and the aquatic bed habitat. Additionally, I will also discuss how waterfowl and waterbird use has changed at Emiquon throughout this time as well. Historically, the IRV provided extensive and valuable habitat to migratory waterbirds and other wetland-dependent wildlife. The IRV had many backwater lakes and tributaries which were rich in aquatic vegetation. These vegetation communities often included dense patches of aquatic plants such as pondweeds, American lotus, many different species of annual and perennial grasses, and even water celery. Unfortunately, extensive leveeing and drainage has eliminated many of these natural wetlands, and it has drastically degraded hydrology of the remaining wetlands. Despite the loss and degradation of these important wetlands, the IRV remains an important resource for migratory birds in the region. Fortunately, the Upper Mississippi River and Great Lakes joint venture has made the IRV a priority in restoration, and restoration and reclamation efforts are ongoing to return structure and function to backwater lakes and wetlands in the region. One of the most substantial efforts is the Nature Conservancy's Emiquon Preserve, directly restoring, enhancing, and protecting more than 2,700 hectares of former wetlands and uplands in the central IRV. The Nature Conservancy identified key ecological attributes of specific biological characteristics or ecological processes that would guide and evaluate success of their restoration efforts at Emiquon. Because of the region's historic importance to waterfowl and other waterbirds, several conservation targets and associated KEAs at Emiquon were related to waterbird communities and their habitats. For our wetland monitoring, we mapped all wetland vegetation communities, mudflats, and areas containing surface water at Emiquon during the autumn. We delineated vegetation communities and other cover types using handheld field PCs, and digitized cover types in ArcGIS using field notes and GPS waypoints overlaid on high-res aerial imagery. With this data, we have created yearly vegetation cover maps of the wetland basin at Emiquon. Within the first few years of the restoration, we observed submerged aquatic vegetation and hemi-marsh habitats across much of the wetland. Starting around 2012, we began to observe some signs that the wetland was entering the degenerating marsh stage. Over the next few years, we began to see a reduction in the amount of persistent emergent vegetation and hemi-marsh habitats, and the amount of open water began to increase. In more recent years, TNC has conducted yearly drawdowns of the wetland. From year to year, the intensity of the drawdowns have varied. During years of less intense drawdowns, like 2019, we still observed much of the wetland basin covered with submerged aquatic vegetation. In years where a more intensive drawdown was conducted, like in 2020 and 2021, a greater amount of water was removed from the wetland, and we observed more production of non-persistent emergent vegetation. Additionally, during these drawdowns, we have seen a decrease in the amount of submerged aquatic vegetation across the preserve. But to some extent, this was expected. With less water on the landscape, there was less area available for these submerged aquatic plants to grow. However, over the last couple of years, there has been a further reduction of submerged aquatic vegetation at Emiquon. In 2022, a drawdown was not conducted and water levels remained higher, and we would have expected submerged aquatics to rebound at Emiquon, but we did not observe that. I wish I had the 2022 cover map completed for this presentation, but I am still currently working on it. But I was able to map where aquatic bed habitats were in 2022. Generally, we only observed submerged aquatics around the perimeter of the wetland in areas where the water was only a few inches deep and in some of the ditches. And due to a rather dry summer and fall, much of the area that had submerged aquatics eventually dried and the vegetation was left on mudflats by late September. Each year that we cover map at Emiquon, we calculate the area that is composed of each habitat type. Here we have a graph of the percent of the wetland that was composed of aquatic bed habitat throughout the years. As expected, During the years of the drawdowns in 2018, 2020, 2021, we see a reduction in the amount of aquatic bed across Emiquon. However, this graph again illustrates that in 2022 we did not see a rebound of aquatic bed habitat that we would have expected when the water was not drawn down. In addition to cover mapping habitat types at Emiquon, we also conduct several projects monitoring waterbird and waterfowl use of Emiquon. Many of these monitoring projects have associated key ecological attributes, or KEAs, that TNC uses to guide and evaluate the success of the restoration efforts at Emiquon. Our first monitoring focus is waterbird habitat quality, and TNC has established a set of KEAs focusing on waterfowl and waterbird use of Emiquon. When we look back through the years of these KEAs, we generally see that use days have been in the good range for most species and species groups for the majority of the years, with some falling into the fair range over the last few years. To assess waterfowl and waterbird use at Emiquon, we conduct aerial surveys. These surveys are part of our long-term monitoring project that has been conducting aerial waterfowl surveys of the Illinois and Central Mississippi rivers since 1948. These surveys are flown weekly during spring and fall, and we count all waterfowl species as well as American coot, cormorants, pelicans, and eagles. We use the counts collected during our aerial surveys to calculate use days. And use days are an estimate of how many birds use Emiquon over the survey period. So, in a very simplified example, if 10 ducks used Emiquon for 10 days, 10 ducks times 10 days, that would be 100 use days. So I'll start here with our fall use days. The 4 species groups that I have included here, and that are also included in the KEAs, are dabbling ducks, non-mallard dabbling ducks, diving ducks, and American coot. These graphs show use days on a yearly basis, and the number above each bar is the percentage of use days for the entire Illinois River Valley that were at Emiquon. And as you can see, we observed a peak in use days early on in the restoration, somewhere around 2009 to 2011, and then a general decrease in use days since then for all of these species groups. Now, there are a lot of factors that play into which wetlands waterfowl and waterbirds choose to use during their migration, and many of these factors likely play into these birds' decisions. But very high on that list is the amount of food resources that are available at a wetland. And if we look back at the aquatic bed through the years, we see a very similar trend. Aquatic bed peaked early on in the restoration and has declined since then. Aquatic bed habitats can be very rich and diverse food resources for waterfowl and other waterbirds. Some species, such as gadwall, widgeon, and coot, specialize on foraging on submerged aquatic vegetation. But along with foraging on the actual plants, these habitats can host a very diverse aquatic invertebrate community, and these plants produce seeds which are also consumed by waterfowl. So it's likely that the decline in waterfowl use at Emiquon is at least in part influenced by the decline in aquatic bed habitats. A species where this seems very apparent is the American coot. Like I said, coot are aquatic vegetation specialists, and it makes up a large portion of their diet. At different times throughout the restoration, upwards of 80 to 90% of coot in the Illinois River Valley were found at Emiquon. In 2021, that percentage dropped down to 8%. When we look at spring use days, we see more variation in the trends of the different species groups. Some are increasing, while others are decreasing or staying more level. Here, aquatic bed habitats likely play less of a role in spring as they do in the fall. Much of spring migration for waterfowl occurs before these aquatic plants begin to grow, so it's likely that other factors are the primary drivers of waterfowl use in the spring. For dabbling ducks, the increase in recent years is likely driven by the drawdowns. In many of those years, large portions of the food-rich, moist soil vegetation created during these drawdowns was unable to be flooded during fall migration. But spring rain increased water levels and made this food resource available during spring migration. So that brings me back to the use day KEAs. For the most part, over the restoration, these KEAs have generally been within the good range, with a few dropping into the fair range over the last few years. However, if these trends and declines in use days continue, it's likely that we will continue to see these KEAs remain in the fair range or even possibly drop into the poor range. Our other monitoring focus is waterbird production. When we look at the KEAs, we have three indicators for waterbird production. These KEAs include peak brood density, non-waterfowl species richness, and peak American coot brood density. During the last several years, all of these waterbird production KEAs have dropped into the poor range. To monitor waterbird production, we conduct secretive marshbird nest monitoring and brood surveys at Emiquon. And we can use the findings and trends from these monitoring projects to try to tease apart the apparent decline in waterbird production at Emiquon. I will start with our secretive marshbird nest monitoring. While there are no KEAs that are directly tied to this monitoring, we can use this as a baseline to see some trends in waterbird production at Emiquon. We've conducted secretive marshbird nest monitoring at Emiquon since 2013. In general, this project is a bit more closely tied to the persistent emergent and hemi-marsh habitats throughout Emiquon, but several of the secret marshbird species that we monitor and their broods also consume submerged aquatic vegetation or the aquatic invertebrates that are present within this vegetation. For this project, we randomly select locations within persistent emergent or hemi-marsh habitats and search a 25-meter buffer around each location. And any marshbird nests that are located within these plots are then monitored weekly until they hatch to determine nest success. Over the 10 years of this project, we have searched 790 random plots and have found 611 active waterbird nests. The most commonly found nests were from common gallinules, least bitterns, black-crowned night herons, and American coot. Generally, over the past decade of nest monitoring, we have observed a slight decrease in the nest survival of our two most commonly nesting waterbirds, the least bittern and the common gallinule. And this is likely tied to the decrease in persistent emergent and hemi-marsh habitats at Emiquon. Along with decreasing in size, the patches of these habitat types have also become more linear and narrow, which is likely allowing easier access to nests from predators. But although the amount of nesting habitat has decreased at Emiquon, we have seen that the number of nests at Emiquon has stayed relatively consistent for these two species. When we look at species that are more closely tied to submerged aquatic vegetation, we see a bit of a different story. The two species that are most dependent on submerged aquatics are likely the American coot and the pied-billed grebe. For American coot, a large portion of their diet is composed of submerged aquatic vegetation. American coot were one of our most common nesting secretive marshbirds during the first 5 years of monitoring, but since the start of the drawdowns in 2018, we have only documented 4 American coot nests at Emiquon. As for pied-billed grebes, grebes generally construct their floating nests of submerged aquatic vegetation. Overall, we have found a lot less of their nests compared to coot throughout the years, but we have not documented a pied-billed grebe nest at Emiquon after the drawdowns began in 2018. In addition to nest monitoring, we also conduct brood surveys to monitor waterbird nesting at Emiquon. Since 2008, we've conducted bi-weekly brood surveys at 4 locations across Emiquon from May through August. Our surveys begin at sunrise, and we scan wetland habitat using spotting scopes or binoculars to find and identify waterbird broods. We use the data we collect to calculate brood density across Emiquon that can be used as an index from year to year to monitor waterbird production. Over the 15 years of this survey, we have documented 1,832 broods of 12 different waterbird species at Emiquon. The most common broods observed across this time period were wood ducks, Canada geese, and mute swans. For the most commonly detected waterfowl species, brood observations and density peaked between 2017 and 2019. Since then, we've seen a decline in brood observations and brood density for these species. This decline occurred around the same time as the wetland drawdowns and decline in aquatic bed at Emiquon. Invertebrate communities within aquatic bed habitats provide an important food source for broods, and the decline of this habitat type is likely a contributing factor to the decline of broods at Emiquon. Although we have seen declines in broods, brood density at Emiquon remains greater than or similar to that of previously published estimates to other wetlands within the Midwest. Brood observations for non-waterfowl waterbirds at Emiquon tend to be much less common. For even the most common waterbird breeders, total yearly brood observations were rarely greater than 5 to 10 broods for these species. Trends of brood abundance for these species are difficult to assess with such sporadic detection. However, brood abundances appear to be declining for many of these species as well. Fluctuations in emergent vegetation communities may explain some of the variability in observations of these species. Waterbird broods, especially American coot and common gallinule, tend to be very secretive and seek dense cover for safety, which makes detection through passive brood surveys difficult. So now back to the KEAs to bring everything together on this apparent decline of waterbird production at Emiquon. When we look at the KEA for peak brood density, we do see a decline in brood density of nearly all waterbird and waterfowl species across Emiquon, and that decline occurred around the same time as the drawdowns and decline in aquatic bed habitats. From our nest monitoring efforts, we have seen a decline in nest survival of non-waterfowl waterbirds at Emiquon, which may be contributing to decreased brood density. For species that rely on submerged aquatic vegetation, like American coot, we've observed a decline in nest density since the start of the drawdowns and decline in aquatic bed habitats. Because of this, it is unlikely that the KEA for American coot brood density will return to the good range without an increase in aquatic bed habitats at Emiquon. When we look at the KEA for non-waterfowl brood richness, we see that the indicator value usually hovers around the poor to fair range of 2 to 3 species. However, because many of these species prefer more dense cover for brood rearing, we know that brood surveys may not be the best way to assess this KEA. If we include species that are known to have successful nests from our nest monitoring efforts, then no year since 2013 would have been within the poor range, and a few years would have actually been in the good range. So although brood density has declined at Emiquon, our nest monitoring efforts show that brood richness likely has not. With that, I would like to thank all of our partners who have helped with this research, and thank TNC for allowing us to conduct research on their property. If there are any questions, I would be happy to answer them.